So next up, we have Brian from Mina Protocol, and he'll be talking about scaling layer ones with ZK.
My name is Brian Mckenna. I'm head of product at Mina Foundation, and we're going to talk about scaling, and we're going to talk in particular about scaling using ZK. So firstly, I'm going to take it back to first principles a little bit and talk about the old blockchain scalability trilemma. I'm going to introduce Mina Protocol, give a refresher. Going to talk about scaling with ZKPs in particular, and then talk about some of the projects that are building interesting things on Mina at the moment. Okay. So many of you have probably seen this before. This is the scalability trilemma, where we want to think about the key features that blockchains want to keep, right? So on the bottom left, let's start with security. Security is like a non-negotiable, right? We want to keep our funds safe. We want a network which is really resilient and hard to attack. And it's not something that we can really compromise on. Similarly with decentralization, again, like if we reduce decentralization, we can increase scalability, but ideally over time, we do not really want to reduce decentralization. And what is decentralization? It's quite a hard thing to define. I think for the purposes of this, we can define decentralization as being the power over writing to the network. So like on the left extreme of centralized is like one entity has the power to write to the network, commit transactions, create new blocks. And then on the other side, it's like hundreds and thousands of people reach consensus to be able to agree what the next block should be. And then scalability. So we don't want to compromise on the bottom two. How can we achieve more scalability without compromising the other two? So, I mean, if we look at Bitcoin and Ethereum now, they're two of the most decentralized networks that exist. Bitcoin is like only a few transactions per second. Ethereum is between 20 and 30. So we do have a problem with scaling, and like we need to think about ways of solving it. And we think that ZK is a really good way to do it. You stand here? Okay. So, what are zero-knowledge proofs? So zero-knowledge proofs are, I can give you something where you trust beyond belief that what I have given you is the truth. So this can be a computation, some piece of information, and the inputs to that piece of information don't necessarily need to be known by the receiver, which is kind of cool, especially in regards to privacy, but also in regards to scaling, as we're seeing like currently with ZK rollups on Ethereum. ZK snarks in particular are efficient because they're constant time, constant size, and they give us these cool privacy properties. Okay, so what's Mina? Many of you probably heard of Mina. Mina launched its mainnet 2 years ago, and we're about to hard fork in support for zero-knowledge applications. The current network is what we call a succinct blockchain. It's succinct in that the size of the blockchain remains constant over time. We do this by using zero-knowledge proofs at the base layer of the network. So block after block after block, the state of the previous block is recursively proven right back to Genesis, which in practice gives full node verifiability on phones and browsers. And we think that this is a really good technical design for decentralization, because the actual users of the network don't have to trust a central party to be able to check their balances, check the blockchain, and things like this. So I think it's a really good decentralization feature. Also bridging. We've all seen that bridging has been somewhat of a problem over the last few years. And ZK bridging is still in its infancy. It's not really in production yet, but we feel that ZK bridging is going to be a really important thing in the future. Mina is particularly good at ZK bridging because, as I mentioned, we already have a ZK proof of the current state of Mina That then can be verified in the EVM by an Ethereum smart contract. And in practice, an Ethereum developer can look up Mina account state right in the EVM. And we'll be rolling this out to other EVM chains in future as well. And what it really gives us is like a trustless state-proof bridging, which is really cool. Yeah, so as I mentioned, the next big protocol upgrade from Mina is the introduction of ZK app functionality. So ZK apps are zero-knowledge smart contracts. And why are they cool? Well, they're written in TypeScript using our library snarky.js. They offer general purpose zero-knowledge programmability. And as I mentioned already, they give us cool features in terms of user privacy and like more scalability on the application. And I'm going to get into how that actually works. The recursion itself is powered by Kimchi, which is our proof system, which is a nice applicable name for the conference that we're at. So what kind of things can be built with ZK apps? So let's start out and say a ZK app itself has an off-chain component, and it has recursion. So a ZK app in itself could be thought of as a ZK rollup. And ZK EVMs could also be implemented here using Kimchi. One could build a private payment system of Mina using the ZK functionality. Private voting is something that we're very interested in. So voting application, which keeps user identity private, user votes private, but also proves the integrity of the vote count itself. And that can be scaled off chain and like verified on chain, which is kind of cool. Identity is something that we're going to need. So, you know, proving things about your personhood, your real life on chain, revealing about what those things actually are. And then off-chain verifiable large computation. I'm going to get into this in a minute, but being able to prove like huge computations that run off-chain just by sending a zero-knowledge proof of the correct computation on-chain. So I've introduced ZK apps. Let's just spend a little minute looking at like how ZK apps differ from normal dApps that we think about today. So on a normal dApp, as a user, I'll send my transaction to the network. Each node on that network checks the validity of the transaction. And once it's agreed that it's a valid transaction, it gets committed to state. After that, every new node which joins the network has to re-execute all of those transactions since Genesis. So this is quite a similar diagram, but in Mina, computation happens off-chain. A proof of the computation is then sent on-chain, where the verifier part of the ZK app contract checks the validity of the state update and makes the state update if it's a valid update. What does this mean in practice? Well, on the off-chain part, like the size of that computation doesn't matter because it doesn't affect what gets executed on the network. The only thing generated by the off-chain part is the same like constant size zero-knowledge proof, which is kind of cool because it opens up like larger computations that don't blow up the gas costs because they don't have to be re-executed by all nodes. And privacy. So like snarky.js offers public and private inputs to the developer. So where a user does their computation off-chain, they input something private that doesn't necessarily get revealed on-chain if the developer so chooses, which is kind of cool. So the advantages of this type of a smart contract framework, so user privacy, constant size gas, recursive composability of rollups, proofs, contracts, and accessible for non-cryptographers, which is important because this type of programming was only available to like people who really understood the underlying ZK cryptography a few years ago, and we feel now that snarky.js itself is a really good entry point for people who want to use privacy and ZK in their applications. I'm not going to take you through the whole roadmap, but I'm going to focus on one particular track, which is relevant to scale. But just as an overview, what does the roadmap look like? So we break it down into 5 tracks. The first is trust minimization. So this is really like a design space where we're designing things that that really cover decentralization. So like full node in the browser, full node in phone, like just the ability to participate in Mina without having to trust a central party for everything that goes on. ZK programmability is about extending like Snarky.js, extending like proof system compatibility like beyond Kimchi, developing Kimchi further, and really just trying to make Mina like the ultimate like ZK execution layer for programs. Settlement layer performance is around making the L1 a better place to execute ZK rollups and like layer 2 things. And I'm going to talk today in particular about Minaverse, which is scaling an interoperability ecosystem on top of Mina as layer 2s, as like a network of layer 2s. And how is this possible? So we already have infinite recursion and succinct proving, which means that like Mina is a ZK native L1, which means that it's highly applicable to being able to settle ZK transactions that get settled down to it from L2s. We already have a trustless interoperability with Ethereum via ZK Bridge. So the next kind of big milestone is to mobilize teams to build this ecosystem of ZK rollups on top of Mina, which through the proof system that we have, we'll be easily able to compose with each other, not just on the same rollup network. Switch? Here. Yeah. Better? Okay. Wait. That's so better. On top of Mina. Both like isomorphic versions of Mina, which is Mina on Mina, but also like app-specific rollups as well. There'll be data availability solutions, shared sequencer, and really like the bones of the ecosystem to be able to allow people to like build their own rollups quite easily. And like all this goes into like basically ZK app chains, and app chains should be able to talk to each other really easily, not just like inter-app, but also inter-L2, and also like really easily back to the L1, and also to other networks, because they'll also be able to use ZK Bridge, so that like just like the L1, like Ethereum is able to read Mina L1 trustlessly, Ethereum should be able to read Mina L2s trustlessly as well. So let's look at some of the projects which are building on Mina right now. As I said, ZK apps are on testnet at the moment, and these teams are getting ready to launch after it gets into production on mainnet. The first one is Lumina Dex. So Lumina is a standard type of AMM that we all know and love, but they're building new kind of properties to the Dex space, especially around ZK KYC and proof of personhood and things like this, so that like the participants in the DEX know that their counterparty has been KYC'd in some jurisdiction or whatever it may be that they care about. But the key part is that the nothing about the identity of that person goes on chain, which means that we can have like regulated liquidity pools and things like this. And they're also going to build in some private pools, so that again, like the transactions are shielded and not every transaction is shown, which will be kind of cool for the DEX space. I mentioned ZKP ID already, but we have a team called Etonic, and there's a link there, who are working on building like compliance solutions for Mina. Compliance solutions in terms of, again, like I'm a resident of X country, I've KYC'd in X jurisdiction, I haven't done lots of bad things, but none of this goes on chain, and like the people who you're trading with can like meet sufficient criteria for whatever it is that you care about. And yeah, so as I mentioned, Minaverse. So we have a couple of teams building in this direction. Basically, there's going to be a better name for this, but right now it's called the Mina L2 stack. You can kind of think of this like the OP stack. And yeah, so basically building blocks for to allow developers to be able to launch their own ZK rollups in an easy way. And many more. I'll just leave this slide open for a second so that you can see the type of things that are being built. Okay, so we have a developer program which is ongoing. It's currently preparing for cohort 2, and applications are now open. And it's called ZK Ignite. And there are many prizes and cool projects coming out of this each round and each cohort. And you can come and speak to me after if you're interested. The best place to get started is the developer channel in Discord. And there is a Mina meetup tomorrow. And I don't have the details, but come and speak to me after and I'll let you know if everybody wants to come. Okay, that's it from me. Thank you very much.